Okay. We're switching to English. Unfortunately, as you can see, I'm pretty stressed out talking publicly in Polish. So I always fall back to English, which is something I feel a little bit more comfortable with, especially speaking in about technology. So this is machine learning on mobile, State of the Union. It's a talk that I gave a while back. Fortunately, not much has changed, so I'm more than happy to do it again. This is the last talk of the day, and unfortunately, in this virtual setting, we're not having an after party. But I do hope that you guys will stick around on Discord, and we can have a proper happy hour, and then just chill and try to network with each other. So let's get right into it. The plan for today is the following. We're going to do a real quick intro and housekeeping phase. And then we're just going to dip our toes into, what the hell is machine learning? I cannot do a quick show of hands because that's what I usually do and ask people, how many of you have tried to do anything with machine learning so far? So we're just have to skip that. Then we're going to gradually move down from high level stuff. So machine learning as an API. I'll talk a little bit about how to take advantage of machine learning and all the good stuff around it without becoming a data scientist. And then we're going to go down and have a look at MLKit and MLCore, which are two competitive sort of frameworks. MLKit is for Android, and MLKit is for iOS, and MLCore is for Android. And then we're going to briefly talk about TensorFlow Lite, which is the lowest sort of level tool that you can work with on mobile devices. And then hopefully we're going to jump into a quick Q&A and follow up in Discord. So that's the plan for today. This is another slide I usually start with, who am I and why should you even care about what I have to say? I work as a chief technology officer at Intent. We have recently rebranded. We were used to called Info Mobile, and some of you may know that company. We've been around for 13 years almost. I'm a mobile developer from pre-iOS days, which is, as far as I know, it's a pretty rare breed of developers who remember how to, how it was to build stuff for Palm OS or Symbian or Windows mobile devices. After the iOS came out and Android, and of course everything changed. But it's good to know, where you're from. I'm a passionate hacker, so even though you can find a number of gray hair up there, you will find me on a number of hackathons, chugging Red Bulls and coding out. I'm an ex-founder. I started a startup, raised funding, went through an accelerator, and then sort of exited out of that startup. It's by far the hardest thing you'll ever do. So it's kind of funny for me when people say that their university was hard, or their driving license was hard. Starting a company is the hardest thing you'll ever do, and I highly recommend that. I do have some venture experience, so I did have an episode of investing in startups, and until up to this day, startups are extremely interesting thing for me. If you are running a startup, feel free to reach out. I'm more than happy to help. I also mentor at a number of accelerators or initiatives that help startups, including Google Launchpad and a number of others. I'm part of, this is something pretty recent. Google started, when they looked at the market and they've seen the obvious lack of talent around machine learning, they started doing those train the trainers initiatives that are aimed for training the next sort of wave of talent that will take machine learning onwards. And I'm part of that. I facilitate machine learning workshops and boot camps. So that's a little bit about myself. A question that I often get asked is machine learning the new mobile? And the short answer is yes. If it wasn't, I wouldn't be talking to you about this. There are many different technologies that were recently sort of catching the wind. Crypto is one of them. But in my in my personal sort of opinion, the machine learning and AI is something that will exceed mobile in its market impact, right? There are literally endless opportunities for building new features of software that will be powered by machine learning. And you can look at, like if you need a sign other than myself telling you, that machine learning is the next big thing, look at Google. On the last Google I/O, they way back when they used to say Google is a mobile first company, and they've been saying this for a very, very long time. Now on the last Google I/O, they rarely said that Google is about mobile. They've said it's AI first company, and that's a fact. AI startups raise way more money than any others. It's an actual statistic. Being in venture fund, I did take a look at many startups, and it's not even a thing. But if you need a sign, then one of these signs can be the fact that AI related startups do raise more money from investors than others. Mobile hardware is catching up. So sort of relating to a question that Kubas asked, right? Since 2010, we've had every year sort of an iteration of mobile hardware catching up and being more performant, up to A13 Bionic, which is sort of state-of-the-art silicon from Apple, which is capable of doing a lot of machine learning. And as you know, Apple is sort of praising itself for not using any sort of backend in order to perform machine learning. They do it all on device, very privately, and therefore they need performant hardware to do that. And they can do that now. I remember personally from my days working with Palm OS. I mean, we didn't even dream about the hardware that we have right now. So and then finally 5G. We all have our tinfoil hats on. 5G is coming, and I greatly believe that 5G is also one of those things that will push machine learning forward and make it present on in places it hasn't been present on. And so yeah, I mean, like just think about the number of times Apple mentioned machine learning last keynote, and it's been many. There are many use cases, very many use cases for machine learning on mobile. These are just some of them. I mean, image classification. So saying that there is something in the image, image recognition, so facial recognition, stuff like that. Image enhancement, so enhancing the image so it looks better to human eye. These algorithms are also powered by machine learning. Smart replies, if you have Gmail on your phone, or it's much more present on Android, but iOS is also catching up. So yeah, smart replies. So based on whatever information you get from someone, a system can suggest a smart reply to you. So you don't even have to reply. You can have system reply to you. I forget the name of this thing, but Google announced last year that they're working on a sort of a bot that will call the restaurant that you want to book a table at, and they will do the booking for you. And that's it, right? Anything related to speech. So speech transcription, so speech to text, speech synthesis, so text to speech, and then translating any of that from one language to another, which turns out to be a pretty hardcore computer science problem. And then smart predictions, right? I mean, like when you shop for stuff, there is a number of machine learning algorithms that take a look at what you shop, and their main objective is to make you spend more money by showing you stuff that is relevant to you, that you are likely to buy because you bought something, right? And again, these are just some of the examples. I know that a few guys that talked today talked about Firebase. If you're an engineer, I highly recommend you take a look at Firebase, because it's a very interesting tool, and one of the aspects of Firebase is machine learning. And Firebase can apply a number of machine learning algorithms on your users and sort of let you segment out the audience that is likely to churn, or the audience that are likely to make a purchase with your app. And therefore, you can use a number of marketing or sales tactics to either convince them to buy something from you, or not have them churn, or to drop from your app. This is something that we do at those Google boot camps, machine learning boot camps. This is like the x-axis of the company's interest of machine learning, and on the far left we have application-based. On the center we have hybrid, and then on the right hand we have research-based sort of interest in machine learning, because it really depends on your business case, how you will implement machine learning in your app or web app or software. So we're just going to quickly go through each and every of those cases to look. So application-based. This is a scenario that is applicable for the vast majority of you guys. Therefore, there are startups or individuals, right? Because we talked about people having side projects and stuff. So you're building an app or a web app or an IoT or an enterprise application, and machine learning is just something that will enhance your product, or make it more attractive to the customer, or broaden its feature set, stuff like that. So the machine learning is just an addition. It's like the cherry on the top. Your core business is outside of AI. You don't do scientific research in the field of AI, and you will take advantage of AI/ML in order to achieve certain business goals. And a good example of that is New York Times. I highly recommend you take a look at that link underneath, where this entire case study is presented by Google. But the problem that New York Times has faced fairly recently is they had a huge collection of photos. New York Times, they are press. They have tons of photographies that are not digitized. They are physical photo, and they wanted to digitize them, right? So they took advantage of Google Cloud Vision API. This is something I'm going to be talking about at least a few times today. And they took advantage of Google Cloud Vision API in order to process, read, and sort of squeeze out the metadata from the images. And I'll show you exactly how they did it in a second. And then AI, it isn't their core business, right? But it let them sort of enhance and preserve their collection of photos. So this is a typical photo that we're talking about. On the left-hand side, you see the forefront of the photo, no big deal. And on the back, you have a ton of metadata. That's how people did metadata before having computers. They pasted stuff on the back of the photos. And you can see that, number one, like the fonts are all different. There isn't a single font used twice on the back of that photo. You have different sizes of text. You even have stuff rotated. It's not pasted. It's not aligned. you have handwritten stuff. You have stamps all over the place, and all of that stuff sort of overlaps with each other. It's even hard, it's hardly readable for a human, let alone for a computer. And so they took that and they piped it through Google Cloud Vision, and this is what they arrived with. I'm gonna share that presentation with you all so you can have a look at what sort of results you can expect. But just looking at that and that previous slide, you can see that it did pretty darn well with capturing all the little details, all the rotated stuff, and picking out that stuff out of the photo that is prone to to being worn out, right? So another great thing is that once you have that stuff, you can then take the result of the Google Cloud Vision API and then pipe it to another AI sort of API that Google offers, which is Cloud Natural Language API. And then you can have some very concrete NLP work done on that stuff. So you can sort of pick out, for instance, geographic locations or dates or any other thing that Google Cloud Natural Language API offers. And so that way you can, and I'll speak about this in a bit more detail in a while, but you can see that going from this to this for a photo is a single API call. So that was application based. We have two more cases to talk about. On the far right, so sort of contrary to what we just said about New York Times, there are startups or companies that are they are focused on research. So they are building their very own machine learning models. New York Times didn't they didn't do anything. They well, other than performing a REST API call, they sort of piggybacked off Google, who have their machine learning models be world class, right? But there are companies that they work on their own machine learning models, and machine learning is in their core interest and business. And a good example of that is American Cancer Society, and they have conducted a very interesting study where they have used an AI platform and built a very custom machine learning model that was then used to help to identify patterns inside images of breast cancer patients. And it turned out that the study was about basically comparing the human result. So they had doctors analyze the photos, and then they had Cloud ML engine do that the exact same work. And the outcome was that it was 12 times faster image analysis with machine learning versus humans, which is just an insane score. And the reasons for that are pretty obvious. We say that pretty often. We're just humans, right? So whenever a human analyzes something, they are prone to their limitations, their fatigue, their bias, which computers are not prone to. And again, down below there is a link to a nice write-up about this case. Now, in the middle, there are companies that are a little bit of both. They do have some research and scientific interest, but are also sort of focused on different stuff. Yeah, so one of the examples of that is General Electric Health, which these guys are, everybody knows GE. They're a huge enterprise, and one of their products is an MRI device, and they enhance that MRI device with a TensorFlow model or framework that sort of calibrated the MRI machine in order to you have to calibrate the MRI device before you use it, and that was something that people did, but I mean it takes time, right? And human time is much more expensive than machine time. Therefore, they implemented TensorFlow to sort of have that calibration thing done automatically for them. And again, you have a very nice write-up of that case on the bottom as well. So that was a little bit of an intro. We're now going to talk or take a little bit of a deep dive into machine learning. So I usually show that slide whenever I talk about something as new as machine learning. I mean, machine learning has been around for a pretty long time, right? But just lately, due to a number of factors, including accessibility of the hardware, advancements in, performance of the hardware. So you as engineers, many of you are probably senior software engineers, and if you're interested in machine learning, you are about to become a junior data scientist. So it takes a little bit of that sort of bravado to suck at something new, but I highly recommend this because I mean, it's the future, and as I told you before, there is a massive gold rush coming towards ML. So it's sort of like Swift. I'm not sure how many of you remember when Apple showed Swift. I mean, before Swift, we've had Objective-C, and that was one move with which Apple sort of leveled the playing field for everybody in business. Everybody was a beginner at the moment Apple showed Swift, and it's pretty similar with machine learning. So there is a lot of jargon or terminology around machine learning, which is very, very, very confusing. And I'm going to take a stab at taking like a 30,000 feet view at machine learning and all the terminology here. So machine learning versus AI versus deep learning. So on the very top, you have AI, which is a short, obviously, for artificial intelligence. And this is a very, very broad term. It means many, many, many different things to many different people. AI sort of splits into narrow artificial intelligence, which is artificial intelligence that is good at very narrow use cases. So classifying cancer images or detecting faces. This is narrow AI. General AI is something that Elon Musk is working towards, and other bright minds in Silicon Valley. And it's an AI that has a general wide capability. Going a level down, we have machine learning, and machine learning is sort of like a method of training algorithms so that they can make predictions, but without you explicitly coding them. So it's essentially a way to for software to teach itself stuff. And then taking a step down, deep learning is sort of a subset of machine learning, and it's inspired by what's going on in human brain. So you have layers upon layers upon layers of neural nets that are each responsible for a specific thing to detect. And then once you pipe data through that layer, you end up with a prediction. But again, like AI is sort of like sex, right? I mean, like everybody, I remember that big data was sort of similar to AI, and everybody says like teenage sex, everybody's talking about it, and nobody knows what it really is. So it's still, I mean, despite, we have like as a industry, we have, AI has been around for, broadly for like, 20 years. We still keep treating it like a teenage sex. So I hope that this presentation will shed some light on on AI and ML and stuff like that. So continuing our deep dive, this is traditional programming, right? Let alone 50% of your work as a software engineer is CRUD, right? Like the typical create, delete, update, and read operations, right? And that sort of boils down to the input is the data and the rules, and then you apply traditional programming on that, and you get the answers. Pretty simple, right? Well, AI workflow is a little bit, or machine learning workflow is a little bit different. So you start with the data and then the answers, right? And then you pipe it through a number of possible machine learning algorithms, and you end up with rules. And then rules are used in a model. And so then you take a different data set, you pipe it through the model, and you receive the predictions. And therefore, the way of thinking about machine learning project is way different than traditional programming. So your typical machine learning workflow will start from articulating a problem. This is this is pretty common for anything considering any project considering computer science. And then you're not gonna dive into writing code, but you're gonna identify the data sources that you have available in order to solve that problem that you just formulated. The next step usually is identify products or tools that you're going to use, and we're going to dive into that in just a second. And finally, the last step is actual coding and building and integrating stuff. I'm a big quote guy, and this is a really nice quote that sort of sums up what I've been just talking about. So machine learning changes the way you think about a problem. The focus shifts from a mathematical science to natural science, running experiment and using statistics, not logics, to analyze its results. And that's from Peter Norwig. He is a director at Google Research. So we talked about a little bit about machine learning and AI and stuff. So how would you go about dipping your toes into machine learning if you have zero clue about any of this? So many companies, especially the big four, or maybe not Apple, but Google, Amazon, and Microsoft, they have a number of APIs that you can take advantage of that expose, you talk to a REST API, and on the back end, they have all the machine learning trickery available to you. They have pre-trained models that you can take advantage of. It's the way to go for you if you don't have the budget or time or knowledge to dive into machine learning properly, right? It's usually pay as you go. So the barrier of entry is literally non-existent. You just integrate the API call and get the results ASAP. You don't even have to train your models, as the models are pre-trained. So I've talked about New York Times using Google Cloud Vision, and Google Cloud Vision is part of Google Cloud Platform, which sort of is like an umbrella for many different services that Google offers. And here you have 4 sort of different silos that Google makes available to you as an API. So you have Cloud Vision, which we talked about. You also have a video AI, which is sort of like Cloud Vision, but for video. You have natural language processing. So if you pipe, a huge amount of unstructured text to that API, it will help you sort of get the entities out of the text, or get the general idea about what the text is about, the sentiment analysis and whatnot. It offers a whole range of things, and also offers translation. I mean, we can of course laugh about how Google Translator sucks in certain scenarios, but it's pretty useful as an API. And if you're not using it for something crazy important, but you just want to translate some some aspect of your app just to get the message across, it's pretty useful. Then stuff related to speech. So you have speech to text, so you can generate text out of the speaking word. You can reverse that, so you can synthesize speech. And then you also have Dialogflow. Dialogflow is a tool that Google acquired a while ago, and it lets you sort of almost without a lot of coding build dialogues, like the name suggests. So if you are thinking about building an app for Google Home or Assistant, or even Amazon Alexa, you will want to use Dialogflow, which will help you get the stuff from any of those devices that the user said, make sense of it, and then reply in a smart manner. And the final thing that I wanted to talk about in Google Cloud Platform section is AutoML. And AutoML is pretty interesting because it's a tool that you pipe data into, and then sort of it does a lot of the machine learning automatically for you. So it will come up with things that you probably didn't even think about. All of these things, all of these services are pay as you go. So, and many of these will have a free tier for you to get started. So I highly recommend at least having a look at these. Obviously, this is just Google. There are many cloud software providers like Amazon, and Amazon will have its competing services to these. So for Cloud Vision product that Amazon sort of has, they have recognition, and they probably have competing services to each and every one of these. We're going to do a real quick Cloud Vision demo, just so you see that I'm not sort of full of crap, and that it actually works. If you go to the homepage of Google Cloud Vision, you can read about a number of their services and what they offer, but they will also let you try the API, so you don't even have to curl that. You can just drag, and this is a photo of me fencing because I'm a fencer in my spare time, and I'm not a robot. And here is a number of stuff that that API will spit out based on that image. So even though the faces are covered with masks, it will sort of precisely locate the faces that are underneath the masks. It will do a number of analysis. It will object detect. So it will detect the footwear, jeans, whatnot. It's funny because it will also label, and fencing is, me as a fencer, I struggle with, the general public not having a clue about this. And it turns out that Google can identify that photo as being related to fencing with a 91% coverage. So it's pretty nice. It will pick up the text. So it will do optical character recognition. And it's pretty darn accurate because you will have a number of, these little things here. It will try and recognize that text and do it pretty well. It will suggest different crops and whatnot, but this is not something that we're going to be diving into. This is just for you to have an idea of what it offers. Back to the presentation. So we talked about the machine learning that you can integrate into your app without knowing anything about machine learning, and you will be integrating that through a REST API. The next step is the native tools from Apple and Google that will enable machine learning on your device. So we'll start with MLKit. MLKit is available on both iOS and Android. It's from Google. It's basically a wrapper around TensorFlow Lite, which is dedicated for, it's a dedicated TensorFlow version for mobile devices, with some steroids in the form of Firebase, for instance. It has a number of pre-trained models that you can basically take and put them to work in your app. So things like text recognition, face recognition, translation, you can do that. You can achieve that without doing any sort of, without having any sort of machine learning knowledge. It's a quick SDK integration, and you're good to go to work with those pre-trained models. Of course, it supports custom model inference. Inference is just a fancy word of meaning get predictions. So you can get predictions from a custom model that you trained somewhere else. And the cool thing is about MLKit that it works both online and offline. Obviously, some of the stuff available online, offline will be limited, but still you are getting some good stuff on device. Obviously, the on device part is free. It's good for low latency stuff. So anything that has to work near real time, you will want to do that on the device itself. It supports OCR, so optical character recognition, but on device will only recognize Latin characters. And then cloud, which talks directly to Firebase. It's free to get started. So again, I highly recommend you guys to give it a go. It has, as you've seen, it has, because it's also talking to Google Cloud Vision for instance, for recognizing parts of the images and stuff. So it's very accurate, and again, it's free to get started, and it's not terribly expensive. As with everything, MLKit from Google does have a competition from Apple. Of course, Apple, they have different culture, that they believe in different things. So CoreML is something coming up from Apple that will let you do machine learning on iOS. It's included in the typical iOS SDK. It does have pre-trained models for things like we just talked about. So you will be able to achieve, face or landmark. So, parts of the face recognition. You can detect text, track certain features. So you can, teach it to track a certain logo, for instance, on a t-shirt, and it will do so. It's obviously optimized for on-device performance. Apple is all about the privacy. They at the last CES, they had this huge banner that, whatever, happens on your iPhone stays on your iPhone, which is not really true, but, let's drink that Kool-Aid. It supports many different machine learning models like neural networks, generalized linear models, or tree ensembles. What's really interesting in the new, and by new I mean the MLKit that's been announced on the last WWDC, we don't know what they're going to announce now this year because it's still happening, but you can retrain your model on device. So you can make it smarter as users use it, which definitely wasn't available before that. A quick example, I don't have a demo to show you, but for one of the startups, it's a pretty well-known photo editor for iOS. I'm not going to disclose the name because I'm not allowed to, but you can probably find it in top 10 image editing apps in the App Store. We've done a tool, an SDK that they used in order to sort of segment out certain elements out of the photo, and we achieved that functionality combining OpenCV and CoreML exactly. And CoreML's role was object detection. So we used a pre-trained model called YOLO, and combined with CoreML, we were able to detect different objects on the photo. And then OpenCV sort of helped us to get the boundaries well and accurately, and sort of copy out. For instance, if you have a photo of this glass, the glass is probably a shitty example, but if you have a photo of an iPhone sitting somewhere and you tap on the iPhone, we can segment out using that SDK. We can segment out the iPhone really accurately out of everything else on the photo. Talking about Apple also has, and it's interesting because not a lot of people know about this. So there is an app that Apple offers. It's called CreateML, and it's a really easy and very user-friendly macOS app, which will allow you to visually build, train, and test and deploy machine learning models with, again, essentially zero machine learning knowledge. So you don't have to be a data scientist to train your own models. You can use CreateML to do that. It's training on your local machine. So word of warning, it will take a long time depending on your data set. I've had it run for, I build it, I'm a cat person, so I have a few cats in my home. So I built a cat face detector, and it's been training for, I think, 18 hours, but I had a pretty big data set as any cat user, but the result is pretty rewarding. It does have some built-in templates for instance, object detection activity or sound classification or providing recommendations. So you can even use some templates that they offer to get, wherever you want to get quicker. And then finally, something for hardcore people, TensorFlow. This is probably as low level as you'll get on machine learning on mobile devices. TensorFlow is, as we know, it's a tool that Google is maintained, and TensorFlow Lite falls into that umbrella. So it's maintained by Google. It's used by a number of prominent startups around the world. It's open source, so we can take a look at its internals. Before that, we had TensorFlow Mobile. Now it's called TensorFlow Lite. Obviously, as with anything, the lower level we get to, the less of a latency we will have. So TensorFlow Lite is very performant on mobile and even embedded devices. So you can deploy TensorFlow Lite-based stuff on not only on headsets, mobile handsets, but also on embedded devices. It also does have, or it comes with, a number of pre-trained models. So I invite you, I'm not going to talk into, I'm not going to dive into a big detail here, but take a look at MobileNets or Smart Reply. These are pre-trained models that will offer, obviously, Smart Reply is something that will let you offer smart replies in your app. MobileNets is it's like a family of mobile first computer vision models that can let you detect as many as probably like 1,000 different objects. And one more really interesting thing is that TensorFlow Lite converter. It allows you to convert and then optimize models from the big TensorFlow into TensorFlow Lite models. So if you have a model that is trained on TensorFlow, you can probably fairly painlessly offer it on TensorFlow Lite using that converter. How do you get started? Poke around. Google Cloud Platform and AWS and Microsoft Azure, they all offer a pretty generous free tier. Many of those services are available for free. You can take a stab at implementing them, come up with features that are powered by these. And I kid you not, there are many things you can think about. Firebase and Google do have code labs. These are very interesting, and to my surprise, they're not really popular. So I invite you to do a MLKit code lab with Google. And then finally, read through the docs. The docs are just the docs, but they are usually accompanied by a number of great examples that you can use in order to get started pretty quickly. So that's about it for the main content. If you want to get in touch with me on most social networks, I'm @Dusker. My email address is peter@withIntent.com. I will share a number of other ways to contact me on Discord. But if you don't have any questions, and I've been looking at the Discord on my iPad here, sadly no questions, but maybe you will come up with some later on. I'll stick around, and I guess that's it. That was very cool. Thank you.